Welcome to Study Loop.
Okay, the question in this question there are two identical bulbs which are connected in parallel. So let me draw two identical bulbs that are connected in parallel, and they are connected to a power source which is of EMF 8 volts, right? And let us consider the current that flows from this power source VI, and the power source also has an internal resistance. So this is the internal resistance small r. This is the EMF E. Okay, and let us suppose this is R1, which is 2 ohms, and this is R2, which is again 2 ohms. And let us consider current I1 flows through this, because I gets divided when it comes to here, and this goes I2. And let us consider the potential across these two resistors B, V. Okay, right. Now, what we can write is, from the circuit, we can write the EMF, total EMF is divided, is obtained by the internal resistance, that is IR, and the resistance R1 and R2, and the equivalent resistance of R1 and R2. Now, since R1 and R2 are in parallel and they are equal, R equivalent equals to R1 parallel R2, and that is 2 parallel 2, which is equal to 1 ohm. So since we need to find out I, the total current flowing through the circuit, so I equals to EMF upon internal resistance plus equivalent resistance, right? Now this equals to 8 upon, now what is small r here? That is given 0.8 ohms, right? 0.8 ohms. So 0.8 plus equivalent resistance is 1. So 1.8. 8 divided by 1.8 gives me 4.44 amperes. Now this current, as it flows from here, gets divided into R1 and R2. Since they are equal, the current is also equally divided. So for R1 equal to R2, for R1 equal to R2, the current are also equal. I1 equal to I2, and it is exactly the half of the total current coming, right? So half of 4.44 is how much? Write it here, 2.22 amperes, right? So we have found the current flowing through each bulb. Now what else? The potential difference across each bulbs. Now it is very easy. The potential difference across each bulbs is the same because they are in parallel. So you can either use I1R or I2R, it is the same, or you can just use I into Req, right? So I1R, let me use I1 into R, so that is equal to R1, 2.22 into 2, right? So this is equal to 4.44 volts. All right, so we found out the potential difference across each bulb, and this is further equal to V2 because they are in parallel. All right, so we found out the potential difference. Okay, we still need to find out the power. So to find out the power, let me separate this, otherwise you may get confused. Okay, so this one was, now to find out power. So power across the first bulb, you can use either of the formulas. Either you can use V1 squared by R1 is R1, or you can just use I1 squared into R1, whichever you want. So whichever you use, V1 squared by R1 gives you 9.85. 9.85 watts. Okay, so this is the same because I1 and V1 are same as I2 and V2. right? And R1 and R2 are also same. So the power delivered to the second bulb is also the same, that is 9.85 watts. Okay, now in part B, this is all part A of the question. Okay, now part B. The question says that in part B, one bulb burns out and its filament breaks, so no longer current flows through. So we only have R2, either R1 or R2. We only have one bulb. So the current now will be 8 upon internal resistance 0.8 plus the resistance there is 2. So 8 upon 2.8, that is equal to 2.86 amperes. Well, the total current of the system decreases, right? It was initially 4.4, but now it's 2.86. But this whole current is received by one of the resistors, right? So the power in either of the resistors is equal to I square R. So this is equal to 2.86 squared into 2, which comes out to be 16.34 watts, right? So now the power dissipated by the bulb is 16.34. Well, previously the power dissipated by the bulb was 9.85. Now the power dissipated is 16.34. So the bulb glows more brightly. Okay, so this is it. So we are at the end of the solution. Thank you for